So today we're really going to take a continued look at factors and zeros of quadratics, except this time we're going to look at those that don't have whole number as answers. That is the roots, zeros, x-intercepts, solutions. They're actually fractions. And that's totally okay to have. So let's just real quick look at two different examples. Here's our first one. 2x squared plus 9x plus 10. To start this off, we'll go ahead and find our a, b, and c and our factor it using our standard method. So we can identify a, b, and c as 2, 9, and 10. Our top of our x gets a times c, which is 20 in this case, and the bottom gets b, which is 9. So as we look at the factors of 20, that is the numbers that multiply to 20, but now they need to add up to make 9, the only possibilities are positive 4 and positive 5. So now that we have our two factors, we can combine that with our original equation to build our new equation. So we take our first term, 2x squared, we add it to our new factors, 4x and 5x, and then we're going to go ahead and pull our last term, 10. Now we need to break it into pieces and group it. So we can look at the beginning of it and say, well, 2x is shared at the beginning. And if you look at the last half, well, we can pull a 5 out of both of those. So we pull 2x out of 2x squared, we get an x back, and 4x divided by 2x gives us a positive 2. If we pull 5 from 5x, we get an x back. 10 divided by 5 is positive 2. So we pull out our GCF of x plus 2, and we multiply by what's left, in this case, 2x plus 5. So there are two factors. Now we need to take each of our factors and set them equal to 0 and solve. So we'll take the first one, x plus 2, set it equal to 0. To solve this, we're going to subtract 2 from both sides, and we get x equals negative 2. And that is our first 0, or our first answer. Our second factor, 2x plus 5, set that equal to 0, and now we need to solve. Notice this is a little bit more difficult because it has multiple steps. So to start it off, we'll start by subtracting 5 from both sides. And we get 2x equals negative 5. From here, we need to separate the 2 and the x. So we're going to go ahead and we're going to divide 2x by 2. And we get x equals negative 5 halves. And that's it. The big point here is to remember that it's perfectly okay to have fractional exponents in your answer. Remember, if you're drawing a graph like this, see here's negative 2, negative 1, 1 and 2, 1 and 2. If you graph it, you might have a parabola that passes in between the whole numbers. And that's okay. Okay? Just remember that it's okay to have these fractions as answers. They don't have to be whole numbers. Let's look at one more example. 6x squared minus 13x plus 6. So let's jump into it just like we did the last one. Here's our a, b, and c. In this case, those are going to be 6, negative 13, and positive 6 again. A times c, which is the top of our x, is 36. And then the bottom will be negative 13, our b value. We look for those factors of 36, the multiple numbers that multiply to positive 36, but are going to add to negative 13. We know that because our top number is positive and our bottom number is negative, they both have to be negative. And if we look at numbers, we should find that 9 and 4 are the only possible values that will multiply to 36 but add to 13. So we've got these, which gets us positive 36 up top, negative 13 on bottom. Now let's go ahead and let's build our new equation. So 6x squared, our first term, we'll add in our two factors, minus 9x minus 4x, and take our last term from the original equation, positive 6. So now we have this new equation, and what can we pull out? We can pull a 3x out of the first half, and we can pull a 2x out of the second half, or excuse me, just a 2. So 6x squared divided by 2x, 3x is 2x, negative 9x divided by 3x is minus 3. Negative 4x divided by negative 2 gives us positive 2x, and 6 divided by negative 2 gives us negative 3. Pull out our GCF of 2x minus 3, and again multiply by what's left over, 3x minus 2. Once again, we're almost there. We need to take our factors and set them equal to 0. So starting off, we have 2x minus 3 equals 0. Multi-step equation again, so we'll add 3 to both sides and get 2x equals 3. Separate the 2 and the x by division. Divide everything by 2, you get x equals 3 halves, or 1.5, 1.5, however you like to write it. So our second root will be 3x minus 2 equals 0. Once again, multiple steps, add 2 to both sides. We get 3x equals positive 2, and then divide by 3. So x equals 2 divided by 3, or 2/3. And that's it. Once again, we've got two roots where both of these roots are fractions. They both come in between whole numbers, and that's okay. Remember, it's okay to end up with these fractional results, and in fact, it's more common. Usually in the real world, you get fractions. The only time you get whole numbers is when a math teacher is designing the problems for you.